So I think we are studying now law of conservation of momentum. Last class, I explained you much about that. So let us write the definition of law of conservation of momentum. And in our today's class, the only important thing we'll study is derivation of law of conservation of momentum. That is what verification. We should verify the law of conservation of momentum is true or not. That's all. So law of conservation of momentum. Okay, so let us see that before going to start this, I want to say that many girls.
Sir, your voice.
Can you hear me, Mari? Am I audible?
Sir, your voice is breaking, sir.
Hello, is it?
Sir, it's clear.
Okay, Mari, just verify it. Okay, so law of conservation of momentum. So if you notice it, we all people studied that for Newton's second law, we use a word called as momentum. So momentum means we know the symbol. What is the momentum symbol, everybody? P. So P is equals to momentum of a body is equals to product of mass into velocity. Am I right or wrong? All of you. So and as we all knows that momentum is a vector quantity or scalar quantity. It is the
Vector quantity.
vector quantity. Okay. So now if it comes to the law of conservation of momentum, so as Mr. Kishore suggested the name, and of course that name is also true for us. So we already knows. So that is what we used to call as Mr. Newton demonstrated this law of conservation of momentum with the help of an instrument called as, what is the instrument? Anybody can tell?
Newton's cradle.
Newton's cradle. Okay. Newton's cradle, C-R-A-D-L-E, Newton's cradle. So I hope you all watched that video which I shared in the group. Am I right, everyone? Newton's cradle.
Yes, sir.
Yes. So if you're not also, so let us watch once again. You can notice here. So this is what the video which is happening. So you can see now he's hitting with how many balls? Only one ball. Do you all remember, all of you? Yes, please.
Yes.
Yeah. And you can see that law of conservation momentum, we can prove it. One ball is not. Now stopping. Now you can see. You can take two balls and you will keep on hitting. You can notice it. Momentum before collision is equals to momentum after collision.
After collision.
So that is only called as conservation of momentum, we used to call it. Now you can see. Have you noticed it or not? So this is only called as Newton's cradle. Understanding, all of you? So we can use another names also. As I shared you the Wikipedia also, you can notice it. This is what we can call it as Newton's pendulum. What we can call, everyone? We can call it as Newton's pendulum. We can call it as a Newton's balls, or we can call it as a Newton's rocker, or we can say executive ball clicker. Executive ball clicker. These many names we can call it. Okay. So as it is, every time it will make a click. Each time the balls will collide. Have you heard a word called as click? Okay. Sir, no.
Yes, sir.
Yeah, that is why we can call it as they are always repeatedly in a steady rhythmic. There is a keep on same rhythmic. Momentum is keep on exchanging. There will be remains the momentum before collision is equals to momentum after collision. So
One doubt, sir.
Yes, Mar.
Sir, during collision, what will happen, sir?
During collision, the momentum will exchange. Okay, Mari. During collision, momentum will be exchanged between the bodies. Okay. So that is what
sir.
it will be happening. So now, of course, you can see that the diagram which I have shown you in the last class, you can draw the same diagram again in your classwork also. So if you have noticed the diagram, first time he is hitting with how many balls? If you have noticed it here, there is one ball he is taking into some other position and he is leaving that so that the ball is going to hit. But these four balls are in stationary. Do you all notice it, everybody? These four balls are not moving, but momentum is exchanging so that again the last ball is going away. Am I right or wrong? All of you? Yes? Clear? So the momentum is exchanging between the bodies. The momentum before collision is equals to momentum after collision. Next time Mr. Newton has taken two balls away and he has been dropped. Then you can see the momentum is Here, these 3 balls will be remains constant, and that the momentum is exchanged to the last 2 balls. So the last 2 balls will do the same oscillation. So momentum before collision is equals to momentum after collision. So this is what Newton's cradle experiment. So which is law of conservation of energy. Even we can use the same for law of conservation of momentum only not. We can use it for verification of what? Law of conservation of everybody. Yes, please. Conservation of momentum also we can prove, and as well as conservation of energy also we can use the same equipment. So Mr. Newton demonstrated this with the help of this. Now you can see if an external force acting on a system is zero, if no, F net, that is what I am saying. Net external force is zero, then the total momentum of the system remains constant. The total momentum of the system of a balls is remains same before collision and after collision. So that is only called as conservation of momentum. Do you all understand, everybody? Please respond, all of you. Write it. Yes or no? If you Purima Puriyada Sulita, then I will go with the further. So if you feel that if you make it, there is no external force acting on a system, means the external force is zero on the system, then the momentum of the balls before collision and the momentum of the balls after collision is remains same, remains constant. That is what we used to call it as conservation of momentum. Write it. If an external force, what is this name, Amma? All of you, Newton's, many names we have. Newton's balls we can call simply, if you want, we can call it as Newton's cradle. Okay, so write it. If an external force acting on a system, external force, if an external force acting on a system is zero, the total momentum of the system remains constant. The total momentum of the system of balls is the same before and after collision.
Sir, remains constant means in which manner, sir?
Means the value does not change. Before momentum, whatever the collision, whatever the momentum, if you calculate,
Zero.
after the momentum, after collision also, if you calculate the momentum of the bodies, it remains equal. That is the meaning.
Yes, sir.
Understanding?
Yes.
So that what is there is no loss in momentum, there is no gain in momentum. Just exchanging momentum will take place. Understand? There is no loss in momentum, there is no gain in momentum, but there is exchange of momentum will be takes place. That is why before collision and after collision, momentum remains constant. The value remains constant. That is what we used to call as law of conservation of momentum. Is it clear? My class, you have to be very in time. Whenever I start the class, I want to see everybody quickly within 1 or 2 minutes. You must join. You cannot take this much time. I am saying you. That is the reason you are not performed very well. Many of you disappointed in the PT1 exam. Only boys they did well. Girls, there is nobody. I don't know what happened this Lakshana and this. Nobody has done. What about this? Your Sabram, you are also nothing. How much your mark? You should work. I am saying you. Don't disappoint me like this because we are doing more than everybody. Mark also should work. If you get marks only, how much you are studying, always your parents will believe. So show dedication, and you are already 9th class, you are rushing into some target. So keep on aiming for that. Don't be like a children behavior till like you are 6th and 7th like behaving. So be very sincere. Particularly I'm saying girls. There is very poor performance from the girls side. I'm saying except 1 or 2. So please understand that. Okay. 30 marks is not sufficient, Abhirami. I'm saying you. Okay, this is what about the conservation of momentum. Shall we go with the verification of law of conservation of momentum? Everybody ready? All of you? Yes. So that is what is our ultimate target of today's class. conservation of momentum, verification of law of conservation of momentum. Now, so as I told you, for example, as we all know that momentum means mass into velocity. Now, generally, I will ask you something, either you understand or not, first speak with me. For example, there is a boy now who is running towards to the east, and there is a boy who is running towards to the west. Or there is a boy who is running towards to the east, and there is another boy who is running towards to the east only. Now, both the cases, both boys are collide. Both boys, what they have done, everybody? They hit each other. And this boy, let me take this boy A and this boy B. Boy A velocity is greater than boy B. So that the boy A will go and will hit boy B after certain distance. Am I right or wrong, everybody?
Sir.
Yes. Now, tell me, if A boy is hitting the B boy, A boy is hitting the B boy, that is what we used to call as action. Then B boy is hitting the A boy, that is what we used to call as what? Reaction. Okay. Now, as I already mentioned at the Newton's third law, when I'm teaching a Newton's third law, irrespective of their masses, always action is equals to what? Irrespective of their size and mass, action is equals to what? All of you? Action is equals to opposite reaction. That is what? Minus reaction. Minus indicating opposite direction. Am I right? We studied or not? All of you? Yes?
Yes, sir.
Now my question is, if A will hit B, then whose momentum will change? Like who will affect? B will affect or A will affect? I want to know. Because of B is hitting by A, then who will affect? B will affect or A will affect? I want to know. Whom you will? Yes? B will affect. Am I right or wrong? Please respond, Ra.
Yes, sir.
Yes.
But
Means-
when sir B will affect, when B is hitting A means, sir.
That's what Mari I'm asking. Because of A is going to hit B, whose velocity will change? Whose momentum will change? B's momentum will change. Am I right or wrong?
Yes.
Yes, sir.
Now, means because of A, who will affect, guys? B will affect. And same way, because of B, who will affect? A will affect.
A.
Right? Same way, if because of A is hitting B, B will affect. Because of A is hitting B, B also will hit A, so that A will affect. Am I right or wrong?
Yes, sir.
Do you all understand or not? Are you getting this point? Yes.
Yes,
So
sir.
if you understand this point, that's clear. Now, for example, I say A is going to hit B. So whose momentum will change? B momentum will change or A momentum will change?
Both.
B momentum will change. Mari, because of A, B will influence. Because of B, A will influence. Are you clear what I'm saying?
Yes, sir.
That is what is needed. So if you understand that point, then we'll go with the heading called as verification of law of conservation of momentum. Mr. Darshan, you also is not focused. Still, you need a lot of things to change behavior and all. Completely focus on studies. So, verification of law of conservation of momentum. So, for this one, all of you observe, we will consider two bodies. So, let's consider two bodies. Two bodies. So, what is the name you want? You tell me. What is your choice? Your choice. Let me take A and B. Okay, guys. So, I am consider two bodies A and B of masses M1 and M2. You can, your choice. Small m, capital M, your choice. Small m, M1 and M2. Okay, guys. And let initial velocities. What is the initial velocity I can take? U1 and respond, U2 be their initial velocities. Any problem for anybody till here? Yes, please. I consider how many bodies? Yes, please. Two bodies.
Two bodies.
Whose mass is I consider as capital M1 and capital M2, and whose initial velocities is what? U1
U1 and U2.
Okay. Now that is what it is. Now, let consider both the bodies are traveling in the same direction. Let both the bodies are traveling in the what direction? Let both bodies are traveling traveling in what direction? In
Same direction.
same direction. Same direction. Do you all understand, all of you? Yes, please respond.
Yes,
So I will consider it. Till here, let me draw the diagram so that you all can understand. So this is the A body. I am taking a same thing. So this is the B body. So both are considered according to our data. You tell me this is A body. Okay. Add text. This is A body and this is what body? B body. Okay. And A body is traveling with initial velocity. What is the initial velocity of the A body, everybody?
U1.
U1.
And initial velocity of the B body?
U2.
U2.
And mass of the A body, M1. Mass of the B body, M2. So this is what is both are traveling. So this is what actually before collision. What is that? Before collision. Clear, everyone? All of you? Understand or
Yes,
not?
sir.
Okay, that is what. Now, after this one, you write a statement. Let two bodies collide with the collision lasting for t seconds. So collision, they collide and the collision lasts for how many seconds, everybody?
T seconds.
T seconds. So they collide each other and the collision lasts for t seconds. So during the collision, definitely their velocity will changes. Am I right or wrong? Will you agree with me or not? All of you?
Yes.
Yes, please
Yes, sir.
respond. During collision, during the time of collision, time of which their velocities will change. Will you all agree with me or not? If the two bodies will collide and the collision will last for a few seconds, after that again they are traveling, so that the velocities will change or not? Please respond, everybody.
Yes, sir. Change.
Yes or no?
Sir.
Yeah. So again I will take the two bodies. So let me draw directly. Now this is what A body, and A body come and hit with the B body. So during collision I will show the sparks. So
Sir, how it will come in it, sir? Because it is on the same direction also.
same
forward
direction. So A velocity is more. Do you understand, Maury? A velocity
Yes,
is
sir.
more than B. Then is it possible? Not possible.
Yes, sir, it's possible. Sir.
Yeah. Then both are will collide. So this is during collision. So during collision, what will happen? We have mentioned it. What is that? Collision will last for t seconds. And during collision, what will happen? There is an impact. Because of A, B's velocity will change. Because of B, A's velocity will change. Am I right? Will you all agree with me? All of you?
Yes, sir. Yes.
That is what. And the collision lasts for how many seconds? All of you?
3 seconds.
Collision lasts
3
for
seconds.
3
3
seconds.
seconds.
And again, after collision, the bodies are traveling, the velocities are changing. Let me take that velocities is V1 and both are traveling with the same direction. Okay, after collision also. And mass of this bodies remains constant, M1, and this mass of this bodies remains constant. What is that, everybody? M2.
M2.
So this is what? After collision. Everybody clear? Yes, please. Yes.
Yes.
Yeah. No, that is what I am taking. So
So
let
V1 final velocity, yes, sir.
yes, Mari. After collision, V1, V2, final velocity. Let V1 and V2 be their velocities after collision. Is it okay, everybody? Agalya, Shivani, Alvin is there or not? After collision. So from the second law of motion, what is your second law of motion? Anybody can tell me? Newton's second law of motion.
Rate of change of momentum
Very
is equal
good.
to net
All of
force.
you should say that is only. So which law is always valid? I told you. Not F equals to ma is always valid. Which is always valid? According to Newton's, according to second law of motion. So we all people have something. Anybody can tell? Rate
V2
of
minus
change of
V1 by
momentum.
delta
Yes. Rate of change of
momentum.
momentum. So which second law is always valid? I told you. F is equals to delta P by delta
Delta
T.
P by delta T.
This is the law which is always valid, but F is equal to MA is not valid every time. So be very careful. So now you respond and tell me. So because of collision, can you tell me what is the rate of change of momentum of A? Anybody can tell? Rate of change of momentum of A. Let me take FA, which is actually vector is a vector. So what will happen, guys? Delta P1 divided by delta T. Let me take R else T, because we have taken collision loss for how many seconds? Collision loss
seconds.
for how many seconds? T seconds. So
T
can I take
seconds.
it as a
T
T?
seconds.
Ma P1
Yes,
means
sir.
change in momentum of A. Is it okay, guys? Everybody clear?
Yes, sir.
Yes, please. That is what. Now, same way, rate of change of momentum. Rate of change of momentum of B. Can you tell me what will happen? Rate of change of momentum of B, which is equals
Sir,
to
delta P2
FB. FB is equals to delta P2 divided by T. Am I right? Will you all agree with me? Yes, please respond.
Yes, sir.
Yes. So that's all. Now, from Newton's third law, what is Newton's third law? We speak fastly. From Newton's third law.
Every action has
Equal reaction.
Newton's third law. Please
equivalent
respond.
reaction.
Newton's third law. I will say every action is equals to minus reaction. Am I right? Everybody, will you agree with me?
Yes, sir.
Yes. You can take reverse also, your choice. You can take FA is equals to FB. What is your convenient, you can take. I am convenient with this, I am taking this. Any problem for anybody?
No, sir.
Okay, guys. So this is according to Newton's third law. So now the force exerted by A on B, always we can say the force exerted by A on B is equals to what? Is equal and opposite. Equal and opposite to the force EX here exerted by B on A. All of you read this statement. Will you all agree with me or not? According to the Newton's third law, the force exerted by A on B, the force exerted by A on B is always equal and opposite to the force exerted by B on A. Will you all agree with me or not? According to Newton's third law, same. Am I right?
Yes,
So
sir.
what, sir?
According to Newton's third law, the force exerted by A on B is equal and opposite to the force exerted by B on A. Am I right? Will you all agree? Yes,
Yes, sir.
Alpin, Agalya, understand or not? Sanjay, Gokul Raj? Yes or no? Please respond, Ra.
Yes, sir.
Now, all of you respond and tell me, what do you mean by delta P1 and delta P2? So delta P1 means change in momentum of A and delta P2 means change in momentum of.
Engine time.
So now delta P1 change in time illa. Delta P1 and same way delta P2. So I want to know, let me see who will say perfectly. What is meant by delta P1 and what is meant by delta P2? I want to know. So I will replace it here.
Change in moment.
Yeah.
Sir, it is in change of momentum, sir. Rate of change of momentum.
Rate of change of momentum, I know, Mari. Rate of change of momentum means far. That is what I want. Change in momentum, not rate of change of momentum. Delta means it is a change in momentum. Am I right or wrong? So FB
sir.
means, all of you observe very carefully. FB means it is delta P2 divided by T. Am I right? Which is equals to
Yes, sir.
minus of FA means what? Delta P1
Delta P.
divided by T. Is it okay, everybody?
Yes, sir.
Yes. Now, all of you understand carefully and tell me, FB means force exerted by B on A. Is it right? If you want, you can write it down. FB means what? Please.
Force exerted by B on A.
Exerted by B on A. Means whose momentum will change? A momentum will change or B momentum will change?
A, sir.
A momentum will change. Do you understand, all of you? Yes, please.
Yes, sir.
Whose momentum will
Sir.
change? A momentum will change. Okay? Means in the sense of delta P2 means, I will say, final momentum of A minus initial momentum of A. Will you all agree with me or not?
Yes, sir.
Yes or no? Everybody?
Yes,
Please
sir.
respond. That is
Yes,
what?
sir.
Because initial velocity of A is U1, final velocity of A is V1. So what is change in momentum formula? We studied already. Change in momentum
Mass
equals to
into
delta P is equals to final momentum minus initial momentum. We studied or not before Newton's second law? Everybody? Yes. So final momentum means what? Final mass. That is what M1. This is also M1. So M1 V1 minus M1 U1. Am I right or wrong? Everybody?
Yes, sir.
Yes.
Yes,
That
sir.
is what it is. Next. Same way. What do you mean by FA? What do you mean by FA, guys? Force exerted by,
A on B.
force exerted, EXER, exerted by A on B. Means whose momentum will change? B momentum or A momentum? B momentum will change. Am I right, everybody? Yes? Respond,
Yes.
Ra. So means delta P1 means in the sense of what will happen? M2 V2 minus M2 U2. Am I right? Agree with me or not?
Yes, sir.
Yes, that's all. So if you understand, this is the only crucial thing. So people will get confused. Delta P2 means M2 V2 minus M2 U2. Am I right or wrong? So but
Sir, what about time, sir? By
time
time.
is same, Mari. We are going to only time remains same, correct? Time is not changes. Time loss, collision loss in T seconds. That's all. Clear? Okay.
Yes, sir.
Then you substitute in the formula. So delta P2 divided by T, which is equals to minus of delta P1 divided by T. Now delta P2 means what, guys? Speak, everybody. M1 V1 minus M1 U1 divided by T, which is equals to minus of M2 V2 plus or minus or minus. Am I right?
Minus.
Minus.
Yes.
So M2 V2 minus M2 V2 minus M2 U2 divided by T. So both the side TT is there. Both are in division. Can I get cancel it or not? Can I get cancelled?
Yes,
Yes,
sir.
sir.
Yes. Then what will happen? M1 V1 minus M1 U1, which is equals to minus of bracket. If you remove the bracket, what will happen? Minus of M2 V2 minus
Plus.
into minus plus M2 U2. Will you all agree with me?
Yes, sir.
Yes. Now, M2 V2 I will bring this side. My M1 V1 I will take this side. So I will write it. M1 U1 will come this side, will become positive. Am I right? M1
Yes, sir.
U1 plus M2 U2, which is equals to this one will come this side. So that what will happen? M1 V1 plus M2 V2. Have you all noticed it, everybody? Yes, please.
Yes, sir.
So if you notice it,
Verification.
this is only called as total momentum what? Therefore, we can say this is only called as what? Total momentum before collision. Before
Collision.
collision, which is equals to this is what? Total momentum.
After collision.
Total momentum after collision. Do you all understand, girls?
Usually we are finding at the first itself, no, sir?
Yes, that is what is our expectation. So before collision, what is the momentum? Write it, everybody. This body momentum is M1 U1. Let me take that is P1. This body momentum is P2, which is equals to M2 U2. So what is the total momentum? P is equals to P1 plus P2, which is equals to what? M1 U1 plus M2 U2. This is considered as a total system. Understand, Nagalya? Shivani? You consider as a total system. If you consider as a single system, so total momentum is this before collision. Will you all agree with me? Speak. Kishore?
Yes, sir.
Now, this momentum m1 v1, this momentum m2 v2. Let me take this is p2 and this is p1. So you consider after collision also this is the system. After collision also this is the system. Then what is the total momentum? P1 plus P2 is equals to total momentum. So what is the momentum? M1 V1 plus M2 V2. So that is what we have to prove it. So we proved or not? Verify it, everybody. Yes. So total momentum before collision is equals to total momentum after collision. Any problem for anybody? You all understand?
Sir.
All of you?
Yes, sir.
Yeah.
Sir, can
Yes,
you
sir.
please
Yeah.
up the screen?
So now here, what is the most important thing you should understand, everybody? Force exerted by B on A means in a sense of what? Whose momentum will change? A momentum or B momentum? A
A.
momentum.
A.
Force exerted by B. Sorry, force exerted by A on B means whose momentum will change? B momentum.
B.
So please be
B.
clear with the 2 points. If you are clear with that, then everything will be clear. Because of A, B momentum will change. Because of B, A momentum will change. Understand, Nivedan? Asini, Vairam School Asini, clear? This is only called as law of verification of law of conservation of momentum. Anybody having any doubt, you can ask me, or else you can start solving very slowly and clearly. So which is always true? Newton's second law of motion, which is always true? dp by delta p by delta t, which is the law, Newton's second law, which is always valid. But F equals ma is not valid always. Is it okay, guys?
Yes, sir.
So remember
Yes,
that.
sir.
Okay. So this is what about verification of conservation of momentum. So please solve it. Neatly you solve it. And you learn it also. But you know that, guys, I think this year it is deleted for you. Your book you verify it is there or not. Let me know, Mari. I think it is deleted. Check it.
Yes, sir.
Yeah,
Only
last year.
third of momentum. After that, there's nothing, sir.
Yeah, nothing. Just they have given directly conservation of momentum formula, I think. Okay, guys. So, but you all need to know till last year they studied everybody. So there is this is the only year you study this. Again, 11 and 12 you won't study. They'll say there you already studied in lower classes. That's what is happening. So please make it. Anybody having any doubt, you can ask me. Okay, guys.
Sir,
Understood?
after third law of momentum, chapter completed, sir.
Yeah, I know that. Nothing is there, Mari. Hardly 2 periods or 3 periods, we can finish that.
Yes, sir.
Yeah. Yeah, somebody is saying something. Abhirami, sir, if so, if the body travels in same direction before collision equals to after collision, what is your doubt? Somebody asked something. Abhirami? Minus something.
Sir.
Yeah, you send something message. Somebody send message, but it's not visible to me. Okay. Are you clear? Everything? Everybody?
Yes, sir.
Somebody
Sir,
having any
can
doubt,
you
you can ask.
yes, sir.
Yeah, finish it fast. We'll solve 1 or 2 numericals so that we can wind up this. And then in next class, we'll solve normal force. Next onwards, completely IIT and NEET syllabus from tomorrow onwards. So everything will go extremely tough. Friction, types of frictions, lot of things. So you will get it, many things from tomorrow. And we are going to study methods of reducing friction and work energy, units of work, power, everything, many things we are will study. I think entire your school syllabus will finish in this chapter only. We can have a glance and everything except gravitation. Okay. So write the question now, numerical, everybody. All of you.
Sir, can you please down the screen, sir?
Yes, make it fast, Mari. All of you complete fastly. Is it completed or not? Any doubt anybody can ask me. Princey, understand Princey? Sangamitrai?
Yes, sir.
Simply saying yes. You must be able to solve after the class. That is what is expectation. Okay. So the question is now, all of you, this is the question. We have to solve it related to momentum. Let me see who will solve very fastly and will make it very quickly. So be ready for that. So I will finish it. Sir, actually my doubt is if a body travel in same direction means before collision is equals to after collision. Yes. Yes, Abhirami, but actually the force exerted by one body is always opposite to the second body. That is why we are taking here minus. Do you understand? Either the same direction or opposite direction, it doesn't matter. Clear?
Okay, sir.
If one body is hitting the second body, definitely the second body will hit in opposite direction only, irrespective of their motion. Clear?
Yes, sir.
Yeah. So next, right. This question, very important question. See that a bomb of mass 6 kg initially at rest means initial velocity is what? Anybody can tell? Speak the way, everybody.
0.
0.
0. Understanding? Initial velocity is 0. Okay. Next, it explodes into two fragments of masses 4 kg and 2 kg respectively. 4 kg and 2 kg respectively. Oh, Kishore is having doubt. Sir, one doubt, sir. The minus is not negative. It's mentioned the opposite body now, sir. Yes, Mr. Kishore. It is minus indicating opposite direction. Clear, Kishore? Okay, Ra?
Yes, sir.
You should mention as a minus because it has to be indicating that it is acting opposite direction. Okay, Kishore?
Okay, sir.
Yeah. So now let me take this question. All of you observe very carefully. There is a very less time. All of you see that there is a bomb whose mass is how much initially? Let me take capital M, which is equals how many kg? Fastly. 6 kg. And as it is in state of rest, so that initial velocity is what?
0.
0. Everybody clear?
0.
0. Means what is the initial momentum? Fastly. Initial momentum, speak. Initial
0.
momentum is equals to M into U,
0.
which is equals to 6 into 0, which is equals to how much, Lingesh?
0.
0. Next. It will explode under two fragments of masses. It will split it into, break it into two pieces. One is 4 kg and another one is what? How many kg? 2 kg respectively. If the greater mass moves with a velocity of 5 meters per second. So after exploding, so that it is final velocity 5 meters per second, greater mass. What is the greater mass? 4 kg or 2 kg?
4 kg.
Then find the velocity of the 2 kg mass. That is what V2 they are asking. So shall we start now, everybody? You should speak. So V1 is 5 meters per second, V2 is this one. So what is the formula? Momentum before collision is equals to, fastly. Everybody, momentum before collision is equals
Is
to
equal
momentum.
After collision.
Momentum after collision. Okay, everybody. So that's all. You can make it. So what will happen? Momentum before collision, mutta, which is equals to, or else you can take formula. So what is that? Capital M into V. Why I took capital M into V? Why can't I take M1 U1 plus M2 V2? Anybody? Join back on my meeting. I'll send the link. Why can't I take? Because there is no two bodies. How many bodies is there? Only
One body.
only one body. Understanding, everybody? So only one body. That is why capital M and capital E. Is it okay, everybody?
Yes,
Yes,
sir.
sir.
Yeah.
Yes,
So that
sir.
is what. So capital MU, which is equals to, what is the formula? M1 V1 plus M2 V2. Because after collision, two bodies are there. After exploding, two bodies are there. That is why I'm taking this. Is it okay, guys? Yes?
Yes, sir.
After collision, two bodies. It is split into two bodies. What is the two bodies? One is 4 kg. Another one is what?
2
2
2
kg.
kg. So that's all it is. So we can substitute it. 0 is equals to M1 is how much? 4 kg. And V1 is what? 5 plus M2 is what? 2 into